Hi, I'm Laurel Chinedu. I'm going to explain all about instrumentation calibration and why it is so vital in the industry. Let's start with an overview of what calibration is and why it is needed. I will then discuss the calibration process and talk about calibration frequency. As we learned in the transmitter lesson, instrumentation is measuring the real-life condition of a plant process. For example, a pressure transmitter is measuring the pressure inside a vessel. The instrument is connected to a control system using a 4 to 20 milliamp current signal. The control system then gives a readout to a control room operator so he can monitor and know the exact state of the plant. But how does the control room operator know that the pressure he is seeing on the HMI screen is the exact pressure that is in the vessel? What makes him trust that this process is accurate and reliable? The answer is simply regular calibration of the instrument that gives him this process output. Using a pressure transmitter as an example, which is monitoring the pressure in a vessel, if the pressure transmitter is not regularly calibrated, you will have readings that you cannot trust, often called fluctuated readings. How do you calibrate a pressure transmitter? The first thing you need to do is to know the test equipment you'll be using. And the next thing is to know the process and the procedures you'll be taking to calibrate these transmitters. Here in Nigeria, we have various labs and bodies and organizations that can calibrate transmitters. It's not rocket science if you know the real and the right thing to do. In UK, UCAS is a body that makes sure and is responsible that all transmitters are calibrated following the required standard procedure. How do you calibrate a transmitter? For you to calibrate a transmitter, you will be needing a process calibrator or a hand pump. This process calibrator will be connected to the pressure transmitter to simulate pressure air that you will use to calibrate the transmitter. Also, you will need to connect a calibrator to a 4 to 20 milliamp signal that will simulate this 4 to 20 milliamp signal. Now, the transmitter will give you two different outputs via the control system, and it will convert our reading into the process that will apply for the various test pressure. When calibrating a transmitter, it is worthy to note that you need to calibrate your transmitters in 5-point frequency, often called 5-point testing range. 0, 25, 50, 75, and 100 are the ranges you will use to calibrate your transmitter. We would now work out if the transmitter is within the required accuracy for specific piece of equipment. For example, a 50% input of the pressure should give you an output reading that is within the range of 50% of the transmitter. Now, when you are done calibrating your transmitter, you need to record your readings in a calibration certificate, popularly called as left reading. With this reading, you will be able to monitor and know the next calibration date of your transmitter. In summary, the first step you do when calibrating your transmitter is called the as found state. This is the advanced state or the as found step. The function of this step or the use of this step is to guide you and make you understand how healthy your transmitter is. And when you are done with the necessary adjustments, by like zeroing the transmitter, you will leave the transmitter in another condition known as the as left state. This as left state is what you will input the values into your calibration certificate. All chains of events you have done during this process is called the calibration procedure of your transmitter. If you enjoyed this video, kindly click on the subscribe button and don't forget to turn on my notification so that you can also get videos from me as I drop them. Thank you.